My name is Tom Skelton. I'm the lab technician here, and we will talk about Archimedes' principle, also known as a buoyancy force. What this force is that if something is immersed in, let's say, water, it will actually seem to weigh less. So I'm going to talk about how we will base the principles of how you will determine the buoyancy force. We'll start off with the idea that some object is simply hung on a spring scale attached to the roof of the ceiling, and we'll draw the free body diagram for that. We have a spring scale here, and I have a pointer showing some register of some weight. So the free body diagram is that you have the weight, or mg, downward. You have the force of the tension number 1, because we'll have a tension 2 later, pulling upward. We have the acceleration of 0. And we can draw the conclusion from Newton's second law that F net equals the mass times acceleration, that the net force on it is 0, and therefore that the magnitude of Ft1 is equal to mg. Now, next thing we're going to do is imagine submerging this in water. So we will picture, then we would have the spring scale with a different deflection on the needle. The difference in the deflection from one to the other represents the buoyancy force. And well, I guess there's some water around this. There we go. Now the free body diagram now is that we still have the weight down, which is unchanged, so that its mass times the acceleration due to gravity. We have a tension, which is what the spring scale represents right here, Ft2 this time, and we also have the F buoyancy upward. Again, from Newton's second law, we can say that mg is equal to Ft2 plus F buoyancy. Now we want to determine the buoyancy force, so we'll just do the algebra here and say that F sub buoyancy is equal to mg minus Ft2 and since mg is equal to Ft1, the reading on the spring scale the first time, we can say it is simply Ft1 minus Ft2. And that's the equation you're going to need. Now your instructor can explain where this comes from in terms of pressure. I won't do that, but what we will do is take a look at the equipment you will be using or would be using to do this experiment.